Hello, this is Ashwin, and today we'll be looking at drawing 3D structures according to the VSEPR principles for chemical molecules. Right, so how do we approach drawing and remembering species that have two electron domains? Well, what are their names? What are their bond angles? Well, that is what we hope to accomplish with this video today. And hopefully by the end of the video you'll be able to understand how to draw these shapes and their respective bond angles. So a shape that contains two electron domains is known as a linear shape. And for the sake of examples, I will only be using C and H elements. This is wrong. This means that I will be drawing incorrect compounds, but you'll be able to understand the shape and bond angles at least. So an example would be, remember these are incorrect examples, but you'd be able to understand the shape and bond angle. Linear, and the bond angle is 180 degrees. 3 electron domains. Bond angle is 120 degrees. However, with a lone pair, the triangular planar, as this is called, the triangular planar becomes a bent or V-shaped bent when it contains one lone pair. So again, these are incorrect examples, but you'll hopefully be able to understand the shape and how to draw them. And this here would be a lone pair. Never mind this. So the triangular planar would normally be 120 degrees. However, with the presence of a lone pair, it becomes a bent shape with 117 degrees as a bond angle. This is because the lone pair of electrons distorts the shape slightly, so that the angle is less than 120 degrees. Moving on to 4 electron domains. With 4 electron domains, you have a or what is called a tetrahedral shape. With a bond angle of 109.5 degrees. Tetrahedral. However, if a lone pair exists, it becomes a trigonal pyramidal. That is, it looks somewhat like this. It's again based on the tetrahedral, which is exactly how I remember how to draw the shape, because it is based like the tetrahedral. And again, the lone pair distorts the bond angle, makes it smaller, so it's 107 degrees. And this is going to be a trigonal pyramidal. And then finally, with 2 lone pairs present, you have the bent or V-shaped and this has a bond angle of approximately 105 degrees, and yeah, bento V-shaped in this example. So moving on to species that have 5 electron domains, these are known as triangular, that is triangular bipyramidal species, and 5 electron domains. So that would look somewhat like this. Remember, the examples I'm giving you are incorrect, and these elements may be substituted for others that are correct. It's just with the interest of showing you the overall structure and bond angles that I'm doing this. So this is a triangular bipyramidal, and as you can see, there are multiple angles, 90, 180, and 120. A lone pair gives a seesaw shape, and it does look somewhat like a seesaw. So you have it as 117 here, 90 degrees here. So again, you have multiple bond angles. Then finally, with 2 lone pairs, you get a T-shaped structure with C, H, H, H. 90-degree bond angle, which can clearly be observed here, so it's not, shouldn't be very difficult to remember that. 2 lone pairs. So the bond angles here are clearly 90 and 180 degrees. You also have, in the event that another lone pair is removed, you have another shape that, according to the VSEPR principles, is known as the linear shape, and the bond angle for this linear shape is, well, you guessed it, 180 degrees, and 180 degrees, and this is known as the linear shape. Now moving on to species with 6 electron domains. These are known as octahedrals. Octa meaning 6, and here you have an example of the structure. There you go. This is your octahedral right here. And as you can see, the bond angles are equal to 90 degrees. One lone pair, however, leads to the formation of a square pyramidal with this being the result. And the bond angles here, sorry, and then you can move on to the square planar shape in the event that another lone pair has been removed. I'm sorry if it's a bit too untidy, just running out of space. And so as you can see, they've just simply removed this, so you can literally just copy the rest. Makes it very easy to remember the structure for these large molecules, which generally give IB students a scare in the exams. Sorry about that. So that's two lone pairs, as you can see. So there you have it. You have the 6 electron domains here with 2 lone pairs removed, so you get a square pyramidal, square planar. And as you can see, this is it. This is what we've done so far. Really, it's very important that you memorize these structures because there are often many IB questions related to this, and a good 7 to 8 marks in each paper devoted solely to chemical bonding and structure. So if there are any questions, please feel free to post them, and I'll get to it as soon as possible. Alright, see you in the next video.